Hello, my name is Denis Radin, and today we're going to talk about migrating web apps to virtual reality. It's a big thing now, virtual reality. It was a promise from 90s, and after 20 years it's there. It's real. Everyone can contribute to virtual reality development and develop software for it, and it's exciting. And I personally think it's really amazing. And all those use cases we see now for virtual reality, like treating people and using it as an artificial drug for people with disabilities who is lying in hospital, treating them and making them feel better. So using of virtual reality in psychology, really a lot of use cases, and they're amazing. Communicating from digital world to our brain. Yeah, Denis Radin. You may find me as Pixels Commander on Twitter and pixelscommander.com. I work in a company called Liberty Global. It's the biggest internet and cable provider in the world. We operate on different names: Unity Media, Virgin Media, Ziggo, UPC, almost all the Europe. I work in Amsterdam. It's the city. It's very liberal. Some things are happening there, channels, hippies, and I have a question to you. Legal stuff, 4 characters. What are your English skills? So no, GLSL. GLSL is a OpenGL shading language. It's already legal on the web. Yeah, it works. So WebGL, we have this WebGL. It works, and it's awesome. So why we were interested in WebGL? So we develop operation system for this kind of set-top boxes. This hardware there is comparable to iPhone 2G, and it's pretty challenging to develop snappy animated UIs, which user enjoy to utilize. We tried a lot of techniques to improve performance. For 3 years, we were crunching browser performance, and as an outcome of that was a Challenger Native workshop, which I do together with Yuri Luchaninov. You've seen him yesterday, I guess. Yeah, there was a lot of lessons learned from this 3 years of optimizing JavaScript and browser for better performance. You probably know that there are 2 ways of displaying graphics to user. You can use a CPU to create image, or you can use a GPU, and most people just say, okay, GPU is fast, CPU is slow. It's like very basic knowledge. Who've seen this video? 1, 2, 3, 4, 5, 6, 7, 8. 8 people of, okay, 10, 11 people of a few hundred, so we'll watch it again. This is a video of Mythbusters. They try to explain the difference between CPU and GPU. And what they say basically, so CPU consider how to put every pixel. Do it step by step, put in pixel as a place, it's considered to be at. But GPU utilize parallel computing. And parallel computing allows us to make it faster. So space, 80 millisecond, reach, blah, 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 blah. GPU painting demonstration, he says. 8,
7, 6, 5, 4, 3, 2, 1.
So yeah, making something in parallel allows to make it way faster. So basically, CPU you can compare with hardly working key. It is put in every line by line, and GPU is something using stamps. Do it very quickly. But not only that. Modern GPU can handle millions of textured surfaces. For us as web developers, it's we can say it's millions of HTML elements. It's textured surfaces is basically what HTML element is. And it's really wondering how big difference is between WebGL and HTML. So with WebGL, you can run way more heavy applications. Now we will try to animate some divs with WebGL and see how many we'll get, and is it possible with. So now we have 4,000, 6,000 divs animating, 9,000 divs animating, 20, 30,000 divs, 40,000 divs animating. Could you imagine doing that with HTML and CSS? I think no. Now we are about 70,000 bunnies, and it still stays around 60 FPS. They have not enough of space to, it's really hard to get some mess, but anyway, our graphics processing units are amazingly fast. If you can utilize it completely, you can do crazy things. It's EMG, and then one more letter S, and it allows you to pick an image. But if you try to display image in WebGL, it's really something different, and then the web developers are too lazy to make that. And this one is not even a low-level WebGL. It's already using a Read.js, and it's a pretty high-level engine for that. So, yeah, it's really verbose. And it's sad. That's why people don't use it. Then we popped up this idea, okay, probably we can do a bit of magic and simplify using WebGL up to this syntax by wrapping some piece of HTML into HTML-GL tag, some custom element, web components. It's the future. It's going to be the future for 10 years. Everybody's saying, hey, web components is future, but it's still not there for different reasons. But I still trust it's going to be. So, yeah, we got the simple syntax. And then we understood, okay, it's probably not only about performance. We can do some nice, neat things by utilizing GLSL. GLSL is a way to... Okay, the resolution is super low, I would say. I never tried to... Okay. Yeah, so it's still HTML application. And... but we have some superpowers here. Because GLSL allows you to give an algorithm for every pixel on the screen, depending on coordinate and color or something. It's using a mass to control basically every pixel. And possibilities here are absolutely endless. So I would suggest to you, if you are bored of JavaScript, for example, and you don't want to go .NET or something like that, you may try GLSL. It's a new language and still UI related stuff. Okay, this talk is not about HTML-GL. I can give another talk just on this one, but doesn't matter. Yes, so we got our goals. It was performant. We got some superpowers in terms of visual effects. And it's one story. The second story that we work not only on improving performance, but just to get our clients excited. So then at some point we understood, okay, VR porn is coming. And it's about entertainment. So basically our department is develop set-top boxes. We are the entertainment department. I don't see, doesn't matter. Entertainment department. So our manager came and said, hey, guys, VR porn is going to be great. Let's go VR. So we have all this WebGL experience, decided, yeah, let's try some web VR, and yeah, sorry. I mean, we are concerned about entertainment trends. How VR works. I'm sure every one of you have a basic understanding how it works. Like we have two eyes, you need some two images put into both eyes to have a stereo effect. It's really, really simple. Like you have some content in 3D, and then you should split it into two images and display with respect to different eyes, like a bit different angle. So going back to the topic of this talk, the question is, okay, first, how we can make it technically. And this one is really easy to do with CSS 3D. Why not CSS 3D? Many of us tried it. It's really easy to use. And yeah, in case someone missed the thing, I will show you a demo. So CSS 3D is really powerful. You can build a, yeah, resolution is not there, but you can easily build a 3D action, CSS 3D. And you can display divs. Like this is a tree, Christmas tree of divs in 3D. So in a theory, we can have two documents with CSS 3D and then synchronize the changes, mutations, and have our app in virtual reality in this way, because thinking simple, all we need is two 3D images with a bit different perspective, with a bit different angle. Would CSS 3D work for porting my web app to VR? No, it will not, because actually it's not that simple. It would be simple if you're going to have really shitty VR experience because of many reasons. So two eyes mean two instances of application, and if one is going to be master and second reflect mutations from master, you'll have some significant delay. You have some change, you listen to changes and apply it to the second eye. Can you imagine what your brain is going to perceive in this moment? Okay, I have a change in this eye. In a few milliseconds, I have a change in other eye. It will lead to sickness. It really can trick your brain and hack it. So, but yes, there is a solution. You can work around it by having one master HTML document, and then rendering and applying mutations to two documents, and then yeah, you have no lag. But it's still not the end of the story. In VR, you would like to have in our world we have a field of view in more than 90 degrees. So actually, you see pretty wide, like 100, 120 degrees. But yeah, if you try to look into a mobile phone or VR helmet, it will be very narrow field of view. So to fix that, manufacturers place lenses in the helmet, and on the screen you should have a distortion. Distortion which then, with the help of lenses, is going to be converted with a wider field of view image to make an illusion that you see wider as you do it in the real world, not only a piece of screen somewhere. So, and also a lens is used to transform light in order to perceive it as infinitely distanced from you, not make eye focused on a close object. You know, if you try to bring some object to your eye, it gives you an idea that this object is close. For tricking this, for cutting this eye behavior, we need this lens. And yeah, here you see how distortion works, and definitely it couldn't be done with CSS 3D. For this one, we need GLSL. We With the help of math, we can describe this change. Like the most distance pixel is from the center of every screen, part of screen, then more distortion we add with respect to a circle equation. This is the first problem we can't achieve with first goal we can't achieve with CSS. And the second one is chromatic aberration, because our eyes are lenses, and then they have some lenses are curved, and then different wave of light have different refraction index. Is going to be differently perceived. Different colors are going to be blurred differently from the center, the more distance they are from the center of the lens. And for this one, we also need a correction. If you try to look at VR helmet and put your eye on the corner, you'll see something like that. Basically, what they do, they correct they inverse the effect. Let's stop this experimental thinking and give you an idea what's technology behind all this stuff. So WebVR is currently the mainstream approach to display virtual reality on the web. WebVR is a set of technologies. It's a family of APIs. First of them is, of course, WebGL, which allows to GLSL everything. So then there is a VR sensors to get position and acceleration of your head, and then there is a gamepad API and extensions to gamepad API to have these super awesome controllers. And then a helmet detection API. Also, the interesting thing for front-end developers that there is a special request animation frame, if you know what I mean. It's a request animation frame, is a callback which allows you to execute on every frame being drawn and rendered by browser. But here you can have not the same frame rate as a display, as the main display you have, but many helmets runs at 90 hertz, for example. So helmet can have individual display rate and individual request animation frame. WebVR is currently supported by Chrome and Firefox themes, not by browsers itself, because you need to download special versions of these browsers. It's not even about nightly builds. It's if you go to webvr.org, there are links. There are teams on both in Google and Mozilla. There are dedicated teams to VR, and they do pretty big investments to VR now, and they have some repositories which maintain them separately from the main one, like VR Chromium and VR Firefox. It's not a big deal if you think about that. I mean, if you have this helmet, it's not a big deal to go to by a link and download another version of browser. But I hope with time it's going to be in every browser. But okay, let's go to it's a big disappointment about WebVR. You may think it's already there in every browser, but there are good things, very good things. If you think about that, Oculus and Vive are very close ecosystems. So it's mostly like app stores, but smaller, more closed. And apps there are huge. Like VR experiences usually are very big, so you should download them like a geek and then try to use them. And still, you should go all this approval process. But WebVR allows to put VR virtual reality experiences just on a website. It's a very big advantage, and big advantage. It's instant. You don't need to download it, and it's a big difference. And many companies actually bet on WebVR, and many companies invest into it. Like real estate companies, if you try if you're going to buy a house, which could be really expensive, like $1 million investment, even to pick candidates, you may like to visit a venue, and then if you want to buy a house in a different country, should you fly to 20 destinations? No, you can go to a house in virtual reality on a website, and then make your choice and go only to 5 locations, and yeah, have it in person. So WebVR is mostly done with React.js. Babylon.js have also a WebVR plugin. How it's done from a code perspective? It's just a few lines of code. And how many people try to develop something with React.js? Okay, yeah, not that many, but trust me, it's not that hard. If you go with React.js, there is really a lot of documentation on that. If you Google for React.js documentation, you'll find it's absolutely amazing. I would say it's the best documentation I ever seen for libraries, with amazing examples. But still, we are coming to this problem that developing something with React.js is amazingly expensive and takes a lot of time. So creating UIs in 3D is hard. HTML, CSS is way more efficient way for you as developer, and product owner will not go crazy when he saw a bill with for development. Why it could be important, and how could be appliance of interfaces in a virtual reality could be. So definitely you can use just regular web application in a virtual reality with by using a standard browser. Every virtual reality ecosystem have a standard browser, so you can surf websites just having them as a separate window. But then what's the benefit of virtual reality then if you have just a flat window with no additional value? So the idea is you can use 3D transforms to give more meaning to 3D space, and have a new generation of websites and 3D experiences. And very big advantage of using web apps in a virtual reality could be, okay, let's review the case with customizing car. For example, your company developed a mobile application for customizing Toyota. Then you may add additional value to for a customer, which is a Toyota brand, by putting her clients into virtual reality in a car and using the same code base, the same web application you did into virtual reality, and make these changes in for a car interior by using the same app you use on a mobile phone or a website. So yeah, there were pretty a few ideas on how you can use it, and I had some time to think about that. And one day I got a mail from a company called Sony Entertainment, and they asked, hey, Denis, can you drop a web app in virtual reality, because we are developing a PlayStation VR and we have some web apps. If you don't know this, Sony PlayStation UI is developed in WebGL. It's a WebKit, custom WebKit build running in some embedded platform. It's pretty powerful hardware they have, but it's a browser. If you use PlayStation, it's a browser in there. So they asked, can you drop some web apps into virtual reality with your HTML app? And I said, no, sorry guys, I can't. It's only a 2D. I shown you the demo, it's only a 2D. And I understood, fuck, it's a missing opportunity. Sony called me, and I said them, I can't. I was really upset, to be honest. Yeah, so a year later, it was a year ago. So a year later, a few days ago, I had an exhibition in Amsterdam where I presented the technology called HTML to VR. And basically, it's based on the second generation of HTML/GL. And there are some performance improvements. There is a better sync with DOMs. So a previous version was did not support CSS transitions. It supported only Velocity.js animation library, so now you can transit with CSS transitions. It's pluggable. It means you can have a renderer as a plugin, for example, 3JS or Babylon.js, or you can have different rasterization engines. And yeah, experiments there, rasterize through SVG or rasterize through Canvas, or maybe rasterize through GLSL, who knows. And yeah, HTML version 2 have 3JS plugin, which means that we can apply it to WebVR. So how it works? It's basically the same flow as HTML. So it rasterizes something to texture and listen for changes. If mutation requires to re-render, it recreates the texture and upload to GPU again. But if it's only a transformation or animation, it just change coordinate of a texture. And this is a pretty performant operation on GPU. Okay, demo time. It's a glitchy eye here. Yeah. So let's. Does the resolution really make me worry? To be honest, it's not common to. So it's a very simple app. Every one of you can develop in a few minutes. Let's consider it's a yacht sailing app. Very simple. You can put it in a mobile. Or sorry, I didn't add it that index. But then you understand why it's still not there. So this one is simple. But if you try to do the same kind of thing in 3D with 3JS, it's going to be really tricky. And it will require a lot of imperative code. You've seen how much code you need to display an image. Where we have this. Oh, come on. Yeah, this one. And then you can imagine what kind of hell is going to be to display these boards and animate. Of course, you can make helpers, but then still you have a really huge code base. Okay, let's proceed with the demo. And here we see absolutely the same web app, but it's dropped to 3D space with some lightning and some animations. It's basically the same transitions we had. They applied by CSS transform Z and transition blah blah blah. And we have respect to all reflections, which is really different from CSS 3D. Even if you don't need a VR, which you definitely can't make with CSS 3D. If you just want to add some 3D spacing and visual effects, you may like this approach because you can put it into WebGL and apply GLSL shaders and effects there. So these kind of things. And as I said, it still stays interactive. Let's try this one. I know that currently there is a recording ongoing, so I would expect it to be slower than usual because screen recording is something. Have some music. It takes some time. Why no sound? Okay, doesn't matter. But it's actually working calculator. I just get it from GitHub, and then put it to 3D space. So yeah, you can make these kind of things. What's next? Being in the end of my journey of developing this thing and preparing to exhibition, I seen a presentation from Oculus and basically Facebook, because Facebook bought Oculus and Mark Zuckerberg is pumping a whole lot of money, his billions into VR because he trusts VR, and probably John Carmack is his friends, they drinking beer together. And then, yeah, they presented a thing called React VR. If someone is concerned about future VR, because it's really still ongoing and it's still going, it's going to be published. It's not released yet, but I got some insights from people that it's going to be also a 3JS. It's not going to be a rendering to a native OpenGL, as some people would expect. And yeah, they try to put a flexbox on it, so you'll be able to develop with React and flexbox as React Native do, but then converted it by passing HTML and CSS. It is a really promising thing, but I think my approach is still very nice because it doesn't require some additional and super fancy libraries. It allows to develop with HTML, CSS. And then we're going to have a bit of commercial here. On 21st of April, the next React Amsterdam conference is going to be there. It's going to be absolutely amazing venue, super neat speakers. And I was asked to give away a few tickets to ones who gave me best questions during questions and answer session. Thank you from the Material Soul. If you have any questions, welcome.
First question will be from here.
Hey, thanks for a great talk. So I just wanted to ask, how widely adopted is the technology right now? Are there any real apps that have been built with this?
With this technology?
Yeah.
There is no real world apps, but there is a client who already paid money to develop a real world app. That's the state. And there are a lot of people interested, and then I'm sure that Sony is still looking for a way. I didn't contact them back. I mean, there is a lot of interest because hype around VR. Yeah. You know, where you have hype, you have money, and then you have project.
Thanks.
Do you know something about A-Frame framework by Mozilla?
A-Frame framework, yes.
How it's related to HTML, GL, or React VR?
Yes, I would say it's really a competitor of React VR, and you know, it's really a painful question. I mean, I like React, but still, I see what Facebook does, and what they could do, they can invest money in A-Frame, because A-Frame is basically very similar to React VR, what they're going to have. It's still 3JS bindings, but for web components, not for React components, but still then can make it. And I see that every time Facebook tries to, not to invest into a community-driven project, but try to develop something on their own, it works well, but still I'm concerned. But yeah, A-Frame is basically nice thing if you want to prototype VR experiences, but I don't think for a large scale it works that well. And yeah, it's still a new conception, comparing to just CSS, new components, new ways to animate and so on. So yeah, I mean, it's one of the main approaches you can go now with to develop VR experiences. Pretty limited, but it works, and there are some production applications that did on that.
Hi. First of all, I would like to thank you for the really interesting topic for me personally, because I am excited about VR as a PS4 owner. I'm even more excited about the recent release of PSVR. Actually, I unfortunately haven't tried PSVR in real life yet, but I'm looking forward to buy a PSVR helmet for myself. My question is, I heard that different devices have quite a different performance requirements. Well, not the performance, but hardware requirements. Like Vive wants you to have a super ultra high-end PC to work well. PS4 is like has less advanced hardware, and so it demands less. Is there a relation between the performance of web VR and the devices, actual devices? So will it be different for different devices, and will it, for example, lag in one for one user who has, for example, Oculus, and perform extremely well for another one who has Vive?
Yeah. I personally think that the future of virtual reality is going to be mobile devices. So the Daydream thing Google presented a few weeks ago in October, it's really nice because it moves virtual reality from a really expensive toy to something. They even produce it of fabric. You know, this new Google helmets? They produce it of fabric because of the reasons they try to make this mental switch that virtual reality is not a super expensive and a complicated device anymore, but this is some accessory. It's like your pants, it's like your hat. You just put your helmet on and you relax and you are still in the same kind of environment you are common to be. And all experiences currently built on the web could be run pretty easily on Google Pixel, for example. Google Pixel is an amazing smartphone in terms of performance. If you compare it to our boxes, set of boxes, I would expect it to be 50 times more powerful than our crazy big piece of. And yeah, so I mean, these mobile phones currently are super powerful. And if you try to display just UI, it can work it out easily. Definitely for games like Doom or something really exciting with a lot of polygons, it should be somehow downgraded, but there are some methods to downgrade details on the fly, you know, control level of details in models and level of details for lightning. I think it's going to be adaptive, like how it's called, graceful degradation of a 3D content.
I also have a question about performance. So, because as far as I know, if you're gonna try Oculus Rift, you need to have super modern graphics card, and with Google Cardboard, you can use some kind of get a helmet of virtual reality. So you can put your phone in this card box and you put it on your glasses. So it looks like you need to use somehow system resources of your laptop or your PC and transmit this graphics to your phone. That's far I get. So do you have some insights how this combination of smartphone, Google Cardboard, and powerful PC, for instance, working together?
Oh, to be honest, I don't know anything about this kind of experiments. All equipment sets are currently being developed, doesn't work like that. So I can imagine that definitely this is possible, but I don't think that some of mainstream vendors like Oculus or Vive, for example, work on something like that. So most common to have, you know, this backpack PC.
Doing a lot of steps, but you show the picture that porn industry is going to drive. What the actual technology the porn industry done for virtual reality?
What the technology?
Yeah, what they provide, how they drive in this technology.
How they drive this technology?
Yeah.
They're one of the first adopters, you know?
I know
yeah,
the result. I mean the real tools, real instrument, what they made. We can see their.
That's a nice question. They invest nothing. I mean, they gave nothing to community except porn. What would you expect from porn makers?
I mean, React VR, they made tool and they made some technology.
Okay, yeah, I got. You know, the improvements they did is in a 360 streaming, like 360 video streaming. It's definitely that's something porn drive. Like with WebRTC, they now can stream 360 stream and convert it to a 360 image. And it's small as well, and you can do it from the web. And I know people in Slovenia who actually do that just on web technology. So you don't install any application, you just go to a website and you can wink with cardboards.
Test. Just a question. you mentioned that Chrome and Firefox have special builds. And what kind of devices I can use with those builds? Or how actually browser in those special builds detect that you use device with VR support?
Sorry?
For example, how browser would detect that you use device with that support?
Yeah, that's so. Yeah, so basically, these browsers, these versions of browsers, are connected to drivers of helmets. So it's basically what's happening on the same track. It's done by Oculus environment. So they use drivers of device and then read information from there, but then they standardize it in the way it represents. It's being told by WebVR standard. There is a specification on V3C, and it's open. And yeah, what they do, they use drivers of a device and present data in a standardized way, standardized by V3C and WebVR specification.
So they are not yet like print media type, so you can. So for example, no, it's just a joke.
Yeah.
I mean, so in the future maybe we would design our web page not only for mobile like a flat, we would have our application in 3D for VR. You would have for usual browser and maybe.
Yeah, I think so. To be honest, I think that there is a lot of applications for VR in development, and it could potentially change. Could potentially change the landscape of development. I've seen a nice demo a few years ago, I guess. Yeah, Rift Sketch. This one is a 3D IDE. And then you do some development here. You can imagine if team sits collaboratively in one virtual place and work on the same React component, for example, making a code and then contributing to the same component, and then see it alive. See it alive, how CSS styling, behavior. Yeah, it's a really nice way to collaborate, especially for remote teams.
Thank you for the speech. React VR, 3JS, it's all about rendering. What about business logic? Do we need, and is there any frameworks, library to work with it?
Business logic, I would not say is going to be special from something we currently have. The really special thing is how it's perceived by user and how user interacts with it. So for example, there are some concerns about private space in virtual reality, because you can be really stressed if something is really close to you. Once you perceive projects very realistically, it could be really annoying or even scary if some window flies on you. And there are some new concepts like safety zone. So they want to introduce it to some standards. It's still not there, not standardized at all. But yeah, there are a lot of concerns about how to build UIs and what a new terminology and new concepts is going to be there. But it's not that much about building a new business logic. So business logic is going to be the same, and I guess like in a few years it's going to be the same frameworks, developing same kind of applications, but there's a different kind of phase. So yeah, you can, I'm sure this time is going to be Angular VR and then.
Sorry, yet one question. What about cousin of VR augmented reality?
So virtual reality versus
no, it's the same. I mean, any examples, ideas in a field which you maybe saw like integration of your product site with, let's say, current location, and then you turn on your camera and it's like.
Yeah. So as you know, augmented reality is already there for years, and Pokemon Go Sync, which was, okay, why we didn't make this earlier? So it's there, just it's still looking for nice appliances. I would say the Sync And 20 milliseconds is the latency of a acceleration sensor in a mobile phone currently. And with the Daydream project from Google, they're going to improve it to 3 milliseconds. And then you'll have way more freedom to use it in augmented reality as well, because latency will give you more, low latency will give you more freedom to create application based on inertia positioning.
Hi, thank you for interesting topic and question I hear.
Yeah.
Do you ready to call back to Sony and give them a solution, or they still want more than modern technologies can provide?
Oh, yeah. Thank you. Yes. I'm going back to Sony, definitely. I did it, I did exhibition, and sure. Okay.
Давайте еще один вопрос.
Thank you. One more question is about visual component of virtual reality. What about audio, some 3D effects for audio sources in the web VR? What about it?
Audio sources in web VR?
Yes. If we have some audio, we should some 3D effects for it if we have some VR experience, not only visual component. Yes.
Yeah, but currently we have this web audio API, which is pretty powerful. If you tried that, it's possible to make a 3D effects there, and yeah, we balance channels and then do this kind of thing. So there are no solutions currently to mix them. You know, if you have a passion about that, if you do a library like that currently, I think it's a nice time for this library, this kind of stuff. So technologies documentation and open source it, you'll be speaking in Berlin next year.
Thank you.